Quit encouraging them. No, yeah. Okay, number 5. Is that where you got to? Okay, so find the extreme values of. So we need to graph this, solve graphically. Mr. App, the top one is a parabola. Opening down, move up 5. So we know this. And then we stop when x is 1, but we don't know what our y value is. How are we going to get that? Ooh, good. You get 3. So it goes through the point 1, 3. Okay, and now graph the line. Well, it's got a y-intercept of 2 and a slope of 1. So when you substitute 1 in for x, you get 3. Okay, is there an absolute max? Where? How would absolute min? There's a local min. Local min at 1, 3. And a local max at a lackle. Well, local min of y equals 3 at x equals 1. Or you could just say 1 comma 3 if you want to do coordinates. Whatever floats your boat. Confirm analytically. So let's pretend that we didn't graph it. But we're going to have to do this arbitrarily. So what we need to do is to recognize that x equals 1 is a corner point. How do we know that? Yeah, changes functions. Changes functions. Yeah, but it's really hard to make that happen. Yeah, yeah. Okay, next one. Step 2. Find the derivative of each of the functions. Find f prime of x for each of the functions. So f prime of x equals negative 4x, and f prime of x equals one. Make them both equal 0 and solve for x. So we know that x equals 0 is a critical point. Critical point. Because that's okay. So definition of critical point is f prime of x equals 0 or f prime of x does not exist. That's this one is that. Sorry, it's going to look like a football play. This one is these two. Corner points, the derivative doesn't exist there, right? So we've got our y values now, or x values. We can go get our y values. When x is 0, what's y? When x is 0 at 1, what's y? There's our critical point. Okay, flip the page. Find the extreme values of ln absolute value of x plus 1, x over x plus 1 squared. Y equals ln num abs x divided by 1 plus x squared, close bracket, close bracket, close bracket. Good. Oh, the first x is we used n deriv. The first x is the variable, and the second x is where you're taking the derivative at. So that when you do comma x as the last x, it means you're taking the derivative everywhere. -5, 5, -5, 5. Okay, so graphing. So it's kind of like a seagull. I don't know what seagulls make noise. What? How's it gullin'? Not going, gullin'? Really? Okay. Is he going to react violently? Okay. Okay, so solve graphically. So what we need to do is to find, it looks like we've got some absolute maximums there and an absolute minimum. So we're going to go second, trace, max. Someone should notice that these functions, this function's symmetrical, isn't it? So if you know the one on the left, you probably know the one on the right. The one on the left is -1, comma 0.69431472. -1. -0.693147.2. So we know the one over here on the right is +1, -0.693147.2. And now we're going to try and find the minimum. Second trace minimum. Ooh, it shouldn't find anything. Yeah, it shouldn't find anything. Here's why I know. What's happening here, kids? It's an asymptote. It's actually dropping off the page. No minimum. You missed that? No minimum. Okay, confirm analytically. Take the derivative. Okay, before we do that, you have to think about domain. So, there are rules that you're not allowed to break in this course. You're not allowed to divide by 0. Not allowed to log a negative number. Well, you're not allowed to log 0 either. And you're not allowed to square root negatives. So, are you ever dividing by 0 here? 1 plus x squared. No. It's like grandma. Positive always. 1 plus x squared is always positive. Well, it doesn't hurt that the absolute value symbol around it, right? So, 1 plus x squared never equals 0. But, x over 1 plus x squared can equal 0. This is the log of, you got a ln of the argument. Argument has to be bigger than or equal to 0. Or sorry, just bigger than 0. So, it's never going to be negative because of the absolute value symbol around it, but what value of x will make this equal 0? Thank you. Therefore, x equals 0 is not in the domain. Exclamation point. So we have to be thinking about the domain. Okay. Take the derivative. So, what's the derivative of ln u? Whoa, what? Hey, today's the 28th. What's the derivative of ln u? 1 over u times u prime. What rule do we need? Oh, you guys don't even do it very well. Whoosh rule! Root of the top. 1 times the bottom. 1 plus 1 times 1 plus x squared minus the derivative of the bottom minus 2x times the top x all over the bottom squared. 1 plus x squared squared. Yeah, I know, Mr. Out. That's just about the crappiest way you could write that. But anyways, we could do this. Put that over here. Take this. Put that over there. Put that right there. Oh, I tried. One times 1 plus x squared minus 2x times x all over 1 plus x squared squared. Okay, next step. What? Because what? It will be 2x squared when you clean it up. Yeah, well, you know. Just next. Okay. Now we're going to clean up some more. Somebody had a discussion with me already about this. Mr. Up, you could just do this. One over all of that is just the reciprocal of that. Right? 1 plus x squared over x. And then clean up the numerator of the multiplication statement. So 1 plus x squared, 1 plus x squared minus 2x squared all over 1 plus x squared squared. Yeah? Clean it up a little bit more. Now you're looking at it going, huh? A little bit? Okay, there's two kinds of critical points. The ones that make the top equal 0. Top. The ones that make the numerator equal 0. And ones that make the denominator equal 0. So we're going to solve each of those equations for x. Now you're thinking to yourself, OMG, I have to multiply this out and then factor it. Oh wait, it's already factored. Okay, you never actually want to FOIL in this unless you have to. You always want to leave it in factored form, because when it's time to do something with it, it's already set up, ready to solve. Okay? Now, will this ever equal 0? No. So the only part of the equation that you need to solve is this part. Solve for x. Don't look at me like I don't know what to do. Move the 1, divide by -1, square root, put a plus or minus in front of it. It's a Monday morning thing? Okay. Take a look at the picture. Do those answers work? X equals 1 and x equals -1 are both points on the graph on the left, are they not? Have we found those ones now? Okay. Now, what values of x that make the bottom equal 0? Okay, yes. Why doesn't this matter? Why doesn't that matter? It can never equal 0, and then you square it, it'll really never equal 0. 1 plus x squared won't equal 0. 1 plus x squared squared really will never equal 0. It's like great-grandma. If grandma's positive, great-grandma's really positive. What? No? She's more dead. Okay, those of us who have great-grandmas around right now, they're really positive, are they not? They're a little weird, but they're really positive. Now, what do we know about x equals 0? It's not in the domain. Not in the domain. So we found a critical point that's not in the domain, so we don't count it. It must be in the domain. So we've got our two critical points. They're right here. Those are our critical points. This one's not in the domain. Not in domain. And we're finished. Yes. Yes. Well, just do it. So find the derivative. Take the top, make it equal 0. Take the bottom, make it equal 0. Solve for x in both cases. Okay, go look at your domain. You might throw some of those out. Okay, then go find y values. Okay, flip the page.